Hello and welcome to our next workflow demonstration. So this time I got this scan data of very broken speaker cover, and just before we are going deeper into first steps, we can take a look at this and maybe just slightly brainstorm about what do we actually need to reverse engineer such parts in general. So if I rotate this part more and take a look at more or less planar surfaces, I can see that these are warped quite badly. Same as here is some sort of crack. Probably it was completely broken apart, and from the inside I can see it's been repaired somehow. If it still holds the original shape or not, it's a good question because I have no idea. In general, if I'm looking from this side, probably it might be like one more or less planar surface and another one right here. But good question how it should align to this surface here. So in this case, I'm going to assume this might be like a completely more or less planar, and probably this metallic mesh just doesn't fit completely great there anymore. Probably this one is twisted as well. Oh, we are missing corner on this side. This side also looks quite warped here. Image of this surface, we can see that it's actually quite a lot warped as well. Same come for this one. I really doubt it should be twisted so much. Well, I believe it might be not completely planar, but this warping here, it's most likely simply matter of age and life in the sun and so on. Also, another thing, we want to reconstruct this part with idea to manufacture, to reverse engineer it completely as it should be from factory. First of all, we should get rid of this metallic mesh on top of it to see and actually to have like complete geometry of mounting points of this mesh and all the clips and all the things on the inside of it, because currently you can see it is mounted somehow there, but we don't have any information exactly how it's made, how it's done, and what's the actually design intent of this, how it should be working together and mating. But well, let's try to get best out of it. And of course, in some cases when it's just one of a kind part that you need to reverse engineer for somebody just to make a replacement and you can't source the better ones, sometimes we have to deal with such cases. But in such cases I would prefer actually to have several scans. So one scan might be as it is right now, as we can see it, and probably another scan I would like to see when this part is fitted actually to its mating parts. So probably from mating parts we can understand how straight or curved these edges should be, and probably understand better how this broken off corner should stand and all the things like that, you know. And first thing here, what I would like to do, of course, I would like to align this to coordinate system, at least something closer than it is right now. So probably I'm just going to use interactive alignment. Let's enable coordinate system, and let's try to rotate this part in some more or less logical position. Probably I will start with this one. And then most likely I'm going to switch to front or back view. Close to this. What do we see here? Maybe like this, or let's see the opposite side. Maybe I want to keep this line more or less horizontal. Of course, it's like not that super important because overall geometry with this part doesn't allow us to align it properly to coordinate system. So this should be, I think, good enough. Probably I can move it in general closer to center of coordinate system like this. Okay, let's get rid of coordinate system, and now we can actually start to recreate some surfaces of this part. And as a first surface here, I guess I will try to stick onto this top part, the biggest one. And of course we have many different ways how we can try to do that. So as always, first comes to mind to most users that we could use the fit surface tool because this is like super powerful tool and so on and so on. So let's try to see how this will work in this case. Well, probably I can stick to this segmentation right now, and I'm going to select these segments here as well, these on the side, and probably this one by skipping this broken corner. And let's see, well, can't tell it's too bad or too good. In this case, it doesn't look too bad. Probably, maybe it feels that it has slightly too much curvature here in the middle. Maybe it's not that bad, but if we're looking from side profile, then it's slightly sticking out of the initial shape. So let's turn this transparent and see that actually this is not result what I would like to see here. Okay, so let's just get rid of this one. Probably we can get back to fit surface tool and try this again with maybe slightly different settings. So first of all, I want to remove expansion here. Let's see if it gets better. So in this case, probably it got slightly better, but I feel this left corner goes slightly too low. What else we can try? Well, probably we can unlock view recount and change Y number to 4. But still, this isn't great, and this is not what I would like to see here. So let's abandon idea about fit surface and let's move to some different options. As a next option, probably we can try to create a couple cross sections and loft all this together, or we can potentially create 3D curves that we will try to loft. I'm just going to create 3D curves somewhere around here. Let's enable deviation for this. At this point I can see that I'm quite far away from really nice deviation, so let's pull some points here and there to try to get it better. Okay, so at this point I can see it's not really following the curvature, so probably I would need to introduce a couple more control points. Let's reposition this one. Okay, so probably if we would add more control points, we would get like super good to deviation analysis, but still we have to keep in mind that the more points we're using, the more wobbly or not straight curve we are going to receive as a result. So in this case, probably I can live with these small deviations here. Or optionally, I can create this with like a composite curve, where I would have a straight line in the beginning, then blend all them together. In some cases, this might help, so let's try to do that actually. So for example, I assume this is more flat, but actually I can see it's not flat at all according to deviation, so it should be curved anyway. Let's bring this one back. I'm not going to introduce here any more control points. I'll just exit 3D sketch and I will start another one to create curve profiles actually here, like this, and one on this side. Probably I'm not going to go over the broken up corner, so I will limit it somewhere here. And now again, let's play with control points to try to make it better. It's not getting like super bad or super good, so basically here we can see deviation of something like 0. Maybe 15 millimeters, and I guess that's pretty much good for super old and broken part. Okay, so like this we have two profiles. I'll probably I want to extend this one something like this, let's say, and let's simply try to love them. Let's use this first one as a guide curve. Let's take a look at deviation analysis. Oh, we're quite good on this side. Corner, of course, it's off, and we can see that actually by rotating the scan data, it's way off. This side, well, it's not super perfect, or maybe it is. Just we don't know actually how perfect this scan data is, and well, assuming how beaten up this part did, it's just fine. I would expect this deviation or even much more than this, and so I'm going to ignore it because I want to create this, let's say, smooth as possible. Okay, let's accept this part. Again, let's make it transparent and see that, well, this one actually fits quite nice. This side of metallic mesh is pretty uniform off in terms of deviation. As we can see, it's not that critical. Of course, all these corners, it's like a good question where they should be. But this is quite, I would say, this might be a useful result as well. So, of course, after that, we would just extend all these surface in all possible directions, just to have overlap for intersecting and trimming. But not in all cases this works perfectly. So another thing that I really like in many cases to use is a new Freeform tool. The thing about new freeform is the fact that, well, actually you need much more patience to work with this tool, but it gives you like insane amount of flexibility. I'm just going to create first patch like this. Let's bring on snapping. Let's add here one split like this, and actually I want to create another one here as well. Let's just snap this one point on corner. Okay, so at this point we can see it's way off in all possible ways. What I want to start with is actually to, let's pull back offset slightly. So what I want to achieve here is by moving these control points here to get all this edge more or less green. Of course, I expect to have some slight deviation, and well, I can't avoid that. Once I have achieved all that corner more or less green, and since I have only 4 control points, this surface is like really nice and smooth, I will come over to the opposite side. I will disable snapping, select one edge, click S button to split it. So let's bring back the deviation analysis. Now I can enable snapping again, so I can snap these control points onto surfaces where I want them to be, like this. Okay, so as you can see, this full edge is green, that one is green, this one is more or less good. Maybe I can just change location of this control point slightly, like this. Of course, it's now it's not that easy game to reposition these 4 points to maintain nice curvature. In general, that is possible, of course. So basically, what I would like to do here, first of all, I would start with this edge here and just pull it up close to this result maybe. Now let's just slightly pull this one up as well, like this. So in theory, this might work. Probably I would like to rotate it slightly and see, and I actually have some slight curvature in this direction as well. So basically I don't want to make it with blob on the inside. I want it to have some curvature on the top side. Of course, in this case we can actually work slightly different. So let's get rid of these edges here on this one as well. So now I have one continuous edge on long side, and this one I will keep splitted. So while my snapping mode is off, I'm going to split this once and split this once again. It basically creates me some shape like this. Let's just reposition, or actually on another feature that I forgot about to tell, we have this option, don't move neighbors. So if I will disable this, split this edge once and split it once again, you can see that it places all these edges more or less with equal distance. Of course, it's not like perfectly equal, but it's better than if I have to deal with this by manually moving all this. Of course, I can still come back later to reposition this edge, or maybe just to slightly pull it in one direction, something like this. Let's bring back scan data. Let's enable deviation analysis. And what I want to do right now is just to pull it up until I see this point pokes up through the surface, and the same somewhere here. Okay, so now I can get slightly back and pull this slightly down like this. And essentially now I need to play around with this one to get this region nice and green. So in order to do that, I'm just going to rotate it slightly like this and play around by using local plane movement like this. So basically now again I have achieved nice and green deviation on that side. Of course now I can just pull it slightly in this direction, and I will do the same with this one like this. Again, of course, I can come over back to do some adjustments to make it better, greener, like this. Okay, so by this I ensured that it's more or less flat at the moment. To make it more curved, what I need to do is simply I can just use this edge and pull it up slightly to have it curved in all directions right now. Okay, so I can take a look at the zebra stripes, and I can see that actually it's curved in all directions here and forming really nice and smooth surface. Okay, so once I have done that, most likely my next step would be just to extend this edge. Okay, looks good. So here it's as well green. I'm going to extend this edge in this direction as well. Same goes in that direction and in this direction. Okay, so this is just another way how we can recreate surfaces and still have like tons of flexibility to adjust them. And this is this flexibility that we don't have typically in fit surface tools or in other tools like lofting. So in lofting, if we create profiles and curves, they stay like that, and if we want to change something, we have to go to modify individual curves, and after that rebuild our loft and go to deviation analysis and so on and so on. So that's slightly more complicated workflow, but of course it's great workflow as well, while we keep in mind the fact that we should stick to least possible amount of control points to maintain nice smooth curvature of this part. Okay, so at this point, of course, I can do some slight adjustments on, let's say, this edge to make it closer to deviation by ignoring this small bump here, probably. Like this. This side I'm just going to leave as it is right now. Okay, so when I'm happy with this one, I can move over to neighboring parts, and let's see how and what we can do there, of course. Okay, now moving on to next surfaces. Of course, we can choose whatever any surface, but I think I will go with this front one. And well, to me, it seems like there might be another surface that is just blended together with the first one, or probably intersected and filleted. So in order to get this one, I'm going to use 3D curve here. Let's see, based on reflection, probably I'll try to create this 3D curve somehow this way. Let's see, deviation. Of course, we have some slight tiny deviation here, just above 0.1 millimeters, and I think that should be just fine for this part. So I will accept this one. Then I'm just going to create a plane along this path here, probably somewhere here. Okay, let's make a sketch. And here you can see this pink point. It's a intersection point of my plane and my previously created curve. I'm just going to snap my line to this point and pull it somewhere, maybe like this, and extend it in opposite direction as well. Of course, we can consider this might be as a curved surface, but here we have also deviation for sketches 0.1 millimeters to slice points, and we can see here it's still 0.1. So probably I'm just going to use this as a completely flat line. Okay, so now I can go to Surfacing tab, Sweep, choose no profile, Path, see Deviation Analysis. Yes, in this place it's not like completely perfect, but it is as it is. To be honest, this part is quite messed up, so I'll just flip this surface and let's extend it in this direction. Good. And let's extend in the opposite direction as well, like this. Okay, so we have now two surfaces, and it appears that I would like to extend this one in vertical direction as well. So something close to that. Okay, this looks good. Now I can actually perform a trim here. This, and let's see if fillet gives us some logical result. And here we can see at 17.7, so probably 12 millimeters fillet should fit here quite well, and it seems that I like this result and I'm going to stick with it. Okay, so once this is done, I can move over to, say, backside here, and of course this has some warping as well, so probably I'm going to choose to use here a completely flat surface instead of aligning to all this warping here. Of course, I'm not claiming this is the most correct approach or something, because I have no information about this part whatsoever, how it fits with the rest parts, and so on. So I'm just going to create plane based on three corners that might be most stable on this surface. And from here I can see that actually the sag is not that huge, and probably this might be a flat surface as is when it was designed. Okay, so now I can actually intersect these two as well. Let's trim them, and let's add fillet on this side as well. So here I can see something like 14 millimeters should fit good enough. Okay, so this way I have created a set of top surfaces, and now I'm moving to the side surfaces here. Oh, as I inspected it previously, can see here a lot of warping as well in the middle section of this part. or actually more to the clip. Now I have to figure out how to deal with this one best as well. First thing that I would like to try is actually to fit same simple planar surface is probably based on these points. So let's see, we're quite far on this side. Okay, here we expect to have some deviation. Oh, not great result, so maybe let's try to do some different selections. So probably I still want to keep some selection on this side, something here, and maybe somewhere here. Okay, so this gives me slightly different result here. And of course I have to figure out the best possible way how to deal with this case. And of course, when we're dealing with so much broken parts, we'll have to do many assumptions and figure out on the way how to deal with all of these geometries. Okay, let's try one more time. Or maybe I can just use segmentation tool and see the most average possible result here of complete surface. And to be honest, this doesn't look too bad. And probably actually I could go with this one. Okay, so here we have complete intersection almost. Let's just pull this plane longer like this. Okay, good. So now I can hide these two and move over to this side. And when it comes to this side, it's a little bit more tricky because according to scan data, we should have here like two separate surfaces. While in fact, when I tried to Google this part, I noticed that this should be a single more or less planar surface. So it's slightly more complicated. And again, we have to do some assumptions to follow the scan data that I have right now here, or to just figure out some different geometries that I have no clue about. So in this case, I'm going to simply follow the scan data more or less and try to create some logical outcome of all this. Of course, here, the bottom side, again, it's warped. Again, we have different choices how we can recreate this. If I want to create this as a same code as it's like warped right now, the easiest way would be new freeform, but in general, I know that this is more flat part, and I will just try to ignore this warped scan data and to deal this slightly a bit more logical way. And of course, I will try to fit some planar surface here and see how it actually goes. So if I fit here a plane average to all selection, maybe this result isn't even that bad. Of course, optionally, I can just again manually choose some points that seem logical to me. So for example, one clip, another clip, and probably somewhere here, this more stable corner. And we can see that results are quite a lot different. And of course, this is a good question, which one to align to, and which approach would seem more logical. Of course, in this case, I think this is more logical to have good fitting geometry near the clips that are probably still intact a part of all the rest surface, because we know this corner is broken down, so probably this deviation is logical to be there. And here we have all this complete crack here that was glued later. Probably this one is also good enough. So in this case, I don't know which one would be the better, so I'm going to stick with this result here. Okay, so I have created my first plane here. What can I do at this point? It's getting slightly more complicated, so different approaches again. What I can try to do right now, I will just create a 3D curve that would follow, say, this shade here and through all this part, so it seems straight enough here to be used in the case. So I'm selecting the 3D curve plane, project this sketch, and I'm going to trim actually to delete this face away like this. And now of course I can see that actually that side is poking quite a lot away from the scan data, so it's much more complicated. Probably this shouldn't be so flat, or to be honest, I have no idea. But we can still try to use this plane as a nominal reference and assume it should be like that, and just simply this corner should be sticking more outside than it is right now. Or of course we can always try to follow some different logic here, and maybe we can even go to create, let's say, some sort of 3D curve along this edge. Okay, and now I can simply create plane along path here somewhere, probably here where I have this clip. Okay, like this. Again, let's try to fit a straight line here, so we can see the straight line isn't that perfect example in this case. Probably I can go with an arc here. Like this, let's just extend it in both directions. Okay, hide this plane, surfacing sweep, profile, and path. So as we can see, this top side fits very well to scan data, bottom side not that well. So again, something that we have to assume, is it good or is it bad? Let's try to extend it in this direction. Okay, and let's repeat the same in this direction. And let's see the deviation analysis. So here, actually, it's not that much. It's like 1.5 millimeters away for a broken off part. Maybe it's not bad. Here is also below 1 millimeter. So probably I can play with this. Let's now turn this transparent. Or actually I can, let's say I will create a new 3D sketch here that will follow the same shade. Okay, let's project this. Let's get rid of this face like this. Okay, good. So at this point, I will try to create another plane for here. Let's create a cross-section sketch. And let's try to fit just a straight line in this case. And let's sweep it across all this edge here. So we can see that it's not perfect on this side. It's not super perfect there as well. Can we live with this? Well, probably yes, probably we can. See if it goes like that. You can simply sew these two quickly. Let's actually, before I'm trimming, I will add here fillet. Probably 30 millimeters, like this. So now I can trim these two. Okay, and let's just make a quick test here. How this works. Say 12. Okay, so with 12 millimeters, it doesn't look bad. Let's see again the general deviation analysis. So this corner is like 2 millimeters somewhere away from scan data. And this corner is quite good. Around this metal mesh, it's pretty good as well. We don't have any sags or something, so we're pretty stable on this side. So probably this might be a good result for outer surfaces of this part. Optionally, of course, we can do all this slightly different way. And let's say, let's get rid of this one. This one, I'll probably, let's get rid of sweep as well. I'm just going to keep this cage just in case as a backup. What I can try to do right now is to probably turn this transparent and create a 3D curve on surface just by following this shade somewhere here. So later I can trim all this and try to loft it. So let's try to project the sketch. Okay, like this. So let's get rid of these two faces here. Let's hide this one, and let's try to loft it really quick. Okay, something like this. Here, probably this part. So again, deviation analysis shows it's pretty good. It's not super perfect, but again, we have to remember that we're dealing with really damaged part, so probably this might be as a second option how to deal with this. But at this moment, I have an idea that probably I can actually try one different approach. So let's hide this one, the top surface, and I'm just going to create another 3D curve here. Or this one theoretically might be not that perfect because on this side I'm snapping to this metallic grill, but optionally I can take a look at this approach and see how well it works, just an experiment wise. Okay, so let's create another cross-section sketch here. Fit the straight line, add the plane, surfacing tab, sweep, profile, and path. Okay, so in this case I can see it doesn't align well with the mesh itself. It comes too much over the bottom part. The fixing of profile orientation doesn't change anything much as well. So probably this is not the greatest approach, and actually the ones I had previously I liked much more. So let's try to actually repeat it, what I had here. So this one, I swept this profile along all this edge here. Okay, after that I sewed them together. Let's flip it. Let's add here a fillet. It was 30. Okay, good. So as you saw in previous approach, I had really nice green deviation in this region, but all this was much worse, and of course connection here was much worse as well. So in this case I'm going to, I think, use these surfaces as a better option. Okay, so this side might be done. A part of this last fillet, and I think it was like 12 millimeters. So here, of course, we have a choice what to do. Are we going to create this as a fillet, or we will try to recreate this slightly more beautiful and better flowing? So of course we can go back, delete our fillet here, simply use pipe tool. Okay, so add tangent edges like this. Let's say probably 10 millimeters. I don't need it to be solid, and I want to extend it. Okay, like this. Oh, let's just trim all this. Okay, good. And now at this point we can create of course we can always create one single loft for all this edge, but I don't think it's a greatest option. At least I really don't like to do so, just because it appears as a one continuous surface. Okay, so let's see what's happening here. Okay, probably in this case it doesn't even work, or we can try to dense control. Now it works. So the outcome is just one single surface, and to be honest, I don't like when I don't see these nice edge lines across all these parts that are mating properly. Of course, all of this works, and probably there is no real difference in approach what I'm going to use. But just to showcase different ways how to deal with all this geometry, I'm going to create individual loft here for each segment of these surfaces. Okay, so I will create one here. Next one here. Okay, so in this case, weird way I don't have, yeah, well, it's not weird, it's just because it was a pipe feature and it didn't have any breakpoints here, sadly, so I will have to reposition this manually. Okay, something like this. Let's see. Maybe I can try to move it slightly to make this is a more straight cut. Okay, create and stay on this side. After that, force here. Say tangent.
Like serving his country and being the wonderful father. Now the rest of his life was over. And it was my fault. What are you doing right now? The two.
This one looks good. And for example, I will assume this one is good as well. Okay, and what else? What else? Well, actually, here I need one more. Say this is tangent. Here I want it to be straighter like this. Looks great. And now I'm just going to use fill surface tool. Say alt tangent, create and stay this corner. Alt tangent here as well. And alt tangent here as well. Okay, so now we have much cleaner, nicer edges of faces and overall topology of this surface. Oh, just a different approach how we can deal with all of this. So let's see, I still haven't this very last surface here. Oh no, I had, so it was just a plane. Again, let's trim this. Okay, good. And well, probably on this side I can just use a fillet, just because to use different tools like this. Okay, and on this step I think I will finish this video, and I will just break it into several parts so it's not that super long, because if I'm just following the really quick steps without talking about different options, it takes less time. But now this video will be around 1 hour or even more, so probably I will split it in several pieces, so it's not that complicated to follow up.